Okay, I'm gonna quickly do this stream. I'm a bit hungry, so I'm probably gonna go eat soon, but we will go over this content here. So, R and R Studio Basics. This is the first kind of PowerPoint I think my prof did on EDA, and we'll just cover what it was like. So let's just go over it. Okay, so these are just very basic commands with G and empty cars, and it's printing up the head and the tail and the summary. And what else do we have? Uh, Going over classes, how to use a dollar sign. So it's to select a field of data from a data frame. You can use a simple dollar sign. There's a head, there's a tail, summary showing the MPG cylinder, disposable horsepower, all the different variables along with the quadrants and the different functions that are there. This is the what is this box plot with the minimum, maximum, and the different ranges. And then we have our it's binding certain data to get its empty cars with the cylinder. And what is this? Sinus blue. Well, I don't know what he's doing there. Seems like he's changing the index or something, but not bad. Importing data, so you have to read CSV file and you list the file. And there's this package is very important, the data table package. The prof put this up a lot, so this definitely comes up again and again. And yeah, this fread function is important. It reads different data as well, and then you have to specify the columns with the column dot names, and then you just list them out like this, and then you have the summary of the data, and you can view the data. And yeah, there's a bunch of stuff that you can do with that. Okay, let's keep going. I need to get this done and focus on other things after. So he said dollar sign, data, rating. What is happening here? Rating data, month is 12. Specifically calculating it for that category. Qualitative data. Critical entries known as factors level. Yeah, this was a very important as well. Let's look at things that can be done in the mass library pointers. doesn't really show what the help function for painters to, but I'll search it up. So library maths and 20. I should make a list of the different libraries as well. That seems like it'll be important. Don't want to open it in the file. Let's make one right now. So libraries that are important are important. Data.table, table mass. It has the f-read function in it. What else is there that's important? Is there anything else that he used? No, I don't think so. I don't think he used anything else. That's about that. Okay, let's see what else there is. Um, composition. Oh yeah, he was doing painters. Yeah, with lighting, that's right here. Painters shows all the different painters, factors, levels. There's a facto library in there too. These are all the different painters. What else is it showing? Composition, drawing, color, expression, school. Okay. Painters, money signs, school. Let's make the table a school frequency. Composition, painters, dollars, and composition. Making a table. Which dot max is important too. It helps find the most painters. Which the school function. End row tells you all the rows. Relative frequency distribution. Yeah, it's good too. Quantitative data. It's a built-in air miles data set. Okay, air miles times. Oh, it's a time series. Start and frequency range with air miles. Range of painters and composition. Yeah. Breaks sequence range of air miles. What else? Range of air miles for 2. Do you have anything else that's interesting there? Cut function. Cutting the air miles with breaks and right. So it's summing, coupling relative frequency. Air miles frequency or the sum air miles frequency. And cumulative frequency, I use cum sum for the cumulative frequency. And what else? Frequency, cumulative, relative frequency, and cumulative options. C bind. All this stuff. Okay. You have plots, the cumulative frequencies, breaks. Okay, lines. Oh yeah, besides the lines on it, there's plots with the okay. Breaks, labeling, cumulative frequency. Look how quick the mean as dot numeric. This was important because it makes the data numerical. And we'll put levels into it and add it on numeric. So in the end, there's a median, there's quartiles, there's quantile, range. There's range, empty part, MHE, max minus min, interquartile range, quantile, dimension quantile, table, class. There it is. Standard deviation, covariance coefficient. It's showing all the different calculations, different correlation coefficients. I need to find out how to interpret these results too, because I know he's going to ask that on the quiz. Missing values, NA. That's important too, how to fix the NA values. Okay, what else? Oh, it's different from NA. Quotations. Oh, interesting. It's a true for that one. Okay. The quotations would affect it as well. Interesting. Mean of X. data NA. New data NA. Okay. Data NA2. That's it for this one. It's not bad. We have to go to some more complicated stuff. Not art based. No, that was EVA. Oh, let's go to classification. I know classification is going to be on the test for sure. No, what do that was a PDF. The RMD file I probably can't even see. Yeah, interesting. Let's just go through the PDFs quick times, and then I'll also run through the what's it called? The R files. I had the R files on my other repo. Yeah, I should probably open that up too. And to refresh them and see if I can actually see the R files on other repo. That shouldn't be too bad. I think the .rmd files will work, but we will see. Yeah, they do work. Okay, I will need to review those and test out and see how those work. But in the meantime, I will go over the PDFs and then the recordings and the assignment, and that hopefully should help with the quiz. Hopefully, don't need to make flashcards. Naive Bayes, K&N, Lens Digression, LD, and ABA. Okay. Alright, let's get this done. What else do I have to do here, bro? The classification IDs classifier. I was 25 pages. We'll go end off with this one and come back. Yeah, 83%. And IDB classifier for predicting whether or not online shoppers on an e-commerce website actually purchase a product. So the amount of version of this data set. I need to copy this. This might be useful. Tell me what, bro, let me copy it, man. What the hell? There you go. This is the data set here. The training for it. Libraries, this one. This is a different library as well. I don't remember this. NB1 IB. It's going revenue. Tilde dot. I think that gets all the data. Data is shopping integer subset trainer and this results. Basically discrete predictors. Let's see, wow. Those probabilities, conditional probabilities, interesting. Not what IPs does, prediction. Argument raw to get the probabilities rather than the classes based on values, decision boundary. Now we need to calculate accuracy. Table and we predict shopping IPs, KNN, or ML package. Multiple linear regression. KNN, classic car transition AM automatic 9 over its power weight. First 20 instances of training set of scale test set. Scaling function does not scale data. Scale data first. Scaling data first. Scale training set. Create required inputs. Use the same scaling mean and standard deviation. Train and see bind. Test and train out, test out. Training set inputs, test set inputs. Scale the training set. Retain the names and standard deviations from the training set. Use them to scale the test set according to the same scale as the training set. Means attribute scaled center scales. Now scale the test set according to the training set. Now we create the models this. Then calculate accuracy, okay. And this is the KNN slightly different. And then predictions test out. Yeah, I guess this test in, test out stuff is important. C bind with specific weights. So trained on 1 to 20 and then 21 to 32 for train in and test in, then train out and test out, train in, train out. Okay. Scale the training set, scale it as well. This is for scale attributes, scale center. In the mean concerning the training set, we're using scale test set. According to the same scaling as the training set. Interesting. Required inputs. Scale the test according to the training set. Create the models. Calculate accuracy, KNN prediction 2. Plot the training and testing data for these we can plot patient scale data first. Create plot while all the points training and test. Put labels in the training data. When the prediction is correct, when the prediction is incorrect. Okay, oh yeah, it's important because we need to see the accuracy on it and how much it's validating. So it's data governance in a way. Same plot with actual non-scale data. Art line text. What's this? Okay. HP white, blue, green, red, okay. Different weights. Another example predicting whether or not online shoppers actually buy from the previous data set without scaling. By scaling and seeing results are better. Focus on the numerical variables when using KN. Okay. Online shopping integer. Okay. Then the shopping integer is on this shopping training sample and row. Add inputs. and then prediction two, and great thoughts about all the points, Ministry of Creation, 1 to 50, CQ to 6, means there's a bunch of false, and this one's better because it's telling you it's false and true. Train and test and green metaphors code. Just progression. So it was naive ways, NB with predictions, it was MLR, mobility regression, ANN classification, now logistic regression, administrative duration, remove list, logistic, GLM is general linear model, and horsepower per weight, horsepower, logistic one. Coefficients, intercept, HP, weight is factor 1 degrees from this, no, against, summary, it gives us more information. Coefficients, okay. Some of Superset when was first trained using training data, right? For example, let's predict the default of loan applicants from a default data set. Okay, I choose this one, define classes. Oh, these are all, oh, you can define classes like this by just printing it, okay? Column classes that. So they made it numeric, factor, 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 numeric, factor, and the rest are factors. Interesting. Default of load applicants from a default data set. Interesting. Summary defined. Okay. I'll just continue on them. That's use binomial this time. There's a link for cobra. Interesting. Default. These are all the different variables. Okay. Data, prediction data. Use this predicted zero and this property view prediction data. Okay. Confusion matrix. Another way to calculate accuracy is this. That's not bad accuracy. Instead view this data. Confusion matrix. Use the ROC to calculate their variant of the curve. ROCR. Find the trade-off between accuracy and cutoff. Find the measurement as prediction as numeric. To fix a bunch of R libraries after this, then I have to prepare some presentations and group project as well. Okay. Prediction as numeric, prediction data as numeric this. Okay, plot performance. Okay. Plot ROC.
Before, if you had a CMMS, you had to choose between something with all the functionality you needed or something that was easy for everyone to use. Today's TMS, from Accruent, helps healthcare facility and clinical engineering teams get ahead of their workload and keeps everything at their fingertips. So equipment availability, compliance, and cybersecurity are just normal parts of every day. Say goodbye to clicking through too many menus and spending too much time logging into the system. Now, workflows are streamlined, prioritization is automatic, documentation, data capture, and asset management are a snap. Team members can use any device and any browser, anywhere. Your CMMS should be thoughtfully designed, fast, cloud-based, and enjoyable to use. See today's TMS from Accruent, and keep your facility's equipment up to date and ready for the people who will use it and the patients who rely on it.
This is the Cloud Monster 3. This is 3 layers of cloud tech. And this is a real energy high.
ਚੱਟਾਂ ਦਾ ਏ ਲਾਣਾ
Alright, hope I was on this, not distracted a bit. Loss of JK, AUC, type of AUC, value, comparative tool. Now, instead of first, 20k. And then it goes down, subset equals suffering, binomial. LDA, cause a problem. Predicting observation, critical is not seen as such. Ranges critical stabilization of which is not LDA. Geometric cores, LG0. Efficiency of LDs. LDA predictions, predict this. This was in the classification PowerPoint on page 20. Okay. So, bind histogram. And confusion matrix as well. He might get us to do all of this in the quiz. Tail AR. Data classification action. Partition plot. Yeah, I remember he did this in class for LDA. LD's 1, 2, linear discriminant analysis, and this quadratic discriminant analysis, which is this. Different names. Fusion matrix, factor, partition plot. Okay, I think I'm gonna stop there. I'll come back to the other ones. So I have 2 more modules to review, and then his recordings as well. A tree-based one. See how long this one was. 30 pages. Holy shit! It's definitely a long regression trees, classification trees, and gradient boosting machines. And then add up boost. Yeah, this one's long. Yeah, we'll do it on the next one. Okay, we'll come back.